You're welcome in your maths, and I got a new problem. Today we are going to prove why root 3 is irrational number. So let's go. So as you know that root 3 is real number, and if I consider root 3 as a rational number and if I prove that it is not rational, then it must be irrational number, because real number has two types, rational and irrational. So if it is not rational, then it must be irrational, and that is what we call proof by contradiction. So if root 3 is a rational number, then I can let root 3 as in the form of p by q, where p and q are co-prime number. But why p and q are co-prime? So if I have any rational number, let's say 10 by 30, then I can simplify it as 1 by 3, and now I can't further cut it down, means their SCF is 1, means they are co-prime, they have no any common factor. That means I can always represent a rational number in its simplest form, where they not further divide, and that's the thing I have done here by taking p and q co-prime. And also q not equals to 0, because if it becomes 0, then the fraction becomes undefined. So now squaring both sides, you get 3 is equals to p square upon q square. Now further you can write it as 3q square is equal to p square, and you can clearly see that 3 is a factor of p square. Okay, you can see it here that p square is equal to 3q square, and 3 can divide p square in q square times. So now move to the basics. If prime number can divide p square or a square, then that prime number can also divide a. So I can write a square. First of all, let's say the prime factorization of a is x into y into furthermore. So the prime factorization of a square becomes x into x, y into y, like that furthermore. And these all are prime number. So it is also a prime number dividing a square. So it must be a prime factor of a square. That means it may be x or y or some other. That means that prime number can also divide a, because the a also contains that same prime number. And here also 3 divides p square, so 3 must divide p also. That means I can write p as in the form of 3 into m, because 3 can divide p in some m times. So I can substitute this p in this result. So we get 3q square is equal to 3m whole square, and 3q square is equals to 9m square, and it cancel out and it becomes q square is equal to 3m square. And here also 3 can divide q square in m square times, so 3 also can divide q. So here what we get, that p and q are not co-prime, they have a common factor which is 3, but I have assumed that p and q are co-prime, means the rational number can be simplified and written as in the form of co-prime, but this root 3 cannot be simplified as in the terms of co-prime. But as we know that all rational numbers can be simplified as in the terms of p by q, where p and q are co-prime, that means root 3 is not a rational number. But why it is irrational number? Because root 3 is a real number but not rational number, therefore it is irrational. But why this is real number? So we will clear this in our future video. Hopefully you get it, so don't forget to like and subscribe.